Hi, welcome to video lecture on rectangular plate with a hole. So which is under plane stress condition. In this tutorial, we are going to construct a rectangular plate which is having a dimension of horizontal length 100 mm and vertical height is the 50 mm, and also it is consisting of a circular hole of diameter of 20 mm at its center. First of all, we can see what is a plane stress condition. So if the stress in z direction is equal to 0, then it will come under a plane stress condition. That means we can take in a 2D element. For the 2D element, if it is subjected to a loading on its one of the face, so it is consisting of both the two plane stress condition. That means the stresses which are generated within the object is nothing but the stresses in x direction and also the stress in y direction. But it does not possess any type of a shear stress. That is tau of xy, it is consists. But the shear stress in yz direction and shear stress in zx direction is equal to 0. It is comes under the plane stress condition. The best example of plane stress condition is a rectangular plate with a hole and rectangular plate with a fillet. So whenever the loading is going to be subjected to this rectangular plate with a hole, the load is going to be acted upon the surface edge or on the face of the member. Let us start with how we can do the rectangular plate with a hole stress analysis by using of the ANSYS workbench. In it, first of all, we have to select the static structure analysis. What is static structure analysis means? The structure analysis in a steady load condition, it will come under a static structure analysis. So here we can given the name as a rectangular plate with a hole. This one is the analysis and is totally consisting of a 7 steps. Let us see first step, that is nothing but a engineering data. So in this engineering data, first of all, we can see about the static structural steel. It is a default. So you can see the structural steel. So what are the various material properties required in order to do the design analysis is, number first one is the density, and second one is the Young's modulus, and third one is nothing but the Poisson's ratio. Defaultly, the density of the material structural steel, it is defaultly incorporated by the ANSYS software team itself. That is, its density is 7850 kg per meter cube, and its Young's modulus value is 2 into 10 power 11 Pascal, and the Poisson's ratio value is 0.3. So what is the advantage in that ANSYS workbench when compared with the ANSYS FPDL is that, so we are having the values, magnitude along with the dimension. So if I am change it from Pascal to the megapascal, then automatically see here its value is also varied. So here there is a structural steel is there. In addition to the structural steel, some more material properties are there. So for it we can go for a engineering data sensor. We can click on the general materials so that the variety types of materials are there in this general materials like concrete, copper alloy, magnesium alloy, polyethylene. But for our work, now we can only sufficiently structural steel. So that structural steel is already there. You can see the material properties data. So here in this material property is 200 GPa and then Poisson's ratio is 0.3. 200 GPa is nothing but 2 into 10 power 11 Pascals. So that we can come here 2 into 10 power 11 Pascals. So you can convert to Pascal. So 2 into 10 power 11. So if you are converted to the megapascals, it is a 2 into 10 power 5 Pascal. And Poisson's ratio is 0.3. Okay. Then click on project, so it will comes outside. So first of all, you can see the geometry. The geometry is a question mark. That means we have to create the geometry. Okay. So then here the tick mark will come. Let us see the geometry profile. By double click on the geometry profile will be opened. Once the geometry will be open, so that first of all we have to select the XY plane. So if you see the isometric view, here XY is nothing but front view. So then ZX is nothing but a top view and YZ is nothing but a side view. First of all, we have to consider the XY. So that we have to click on the XY plane. Then we have to click on the look at. So if you are click on the look at, so that it will convert the 3D interface into 2D interface. Then we have to come for a unit. So first of all, we have to click on the units as a millimeter. Then come to sketching. In this sketching, we have to create a rectangle. So that we can create one normal rectangle. After creation of the rectangle, we have given the dimensions. Where here the general dimension, the horizontal line we can assign and also the vertical line we have to assign. Where the horizontal distance, we have to given as a 100 mm. Then vertical distance, we have to assign as a 50 mm. Then we have to, according to our design, we have to create one center circle. So according to it, So we have to create one circle. So again we have to come to draw. Then click on this down arrow so that here the circle will come. So click on the circle so that we can click on a circle. And here the circle diameter, that is by dimension, you can click on diameter, directly taken the general. So how much is the diameter is? That is nothing but 35.338. So you can click on here 20, so that the diameter is 20. Then assign the dimension. So here the center point to this vertical line. Here this length is nothing but a 48. So exactly we want to require a center. The total length is 100. So that we have to assign as a 50. By given the dimension here automatically, so the topology will be varied. So because the ANSYS is one of the parametric software which can acceptable the dynamic changes. In the same manner, we have to assign the vertical length also. So here the vertical length is 25, so that I can click on the 25. So then this one is over. The modeling 2D sketching is over. Then we have to come for a modeling. In this modeling, we have to come for a sketch. Okay. Then given the right click, so that here the isometric view will come. So then we have to come to extrude. So here it is nothing but a plate. So rectangular plate with a hole. Plate is having generally the thickness range is 0.4 to 3 mm. So here for our analysis I am taken the 0.5 mm. So the rectangular plate is a 0.5 mm. The depth. And also come to geometry. So here the geometry we have to click on apply so that it will completely taken the sketch. Then we can click on generate, this thunder symbol. So whenever we can click on generate, so that here the rectangular plate with a hole is going to be created, which is having a thickness of 0.4 mm. Once it is over, then come to the ANSYS symbol. Then see here, so at initially we can told. So basically when you are open, the geometry is consisting of a question mark. After assigning the geometry, it is converted to a tick mark. Then come to model. In it model, we can give a double click on it. So that now the modeling is going to be open. So once it is, it will overall taken the loading of the information. After the information is came, so first of all we have to come on the information like this. First of all we have to click on the geometry, then click on solid. When the solid is click on, here the assignment sectional steel. That means here the sectional steel is defaultly assigned. So whenever the starting in engineering data, we are given here only one, that one is sectional steel. So here when comes to the model, so here for solid automatically the sectional steel will be assigned. So if I want to change any something means, then what I have to do means I have to go for engineering data. Then here I want to create first of all, for suppose general material. So in this general material here I am taken for suppose a stainless steel. If I click on the plus symbol, so that it can come and add to the engineering data sources. Okay. Then comes to that ANSYS profile. I click on the project. So here, if I comes here, okay, then solid textile steel. Then given right click, update. Such that once the update is over, you can come to a model. So here in this model you can see. So default is textile steel. Now here this stainless steel is also command add. Okay. Comes to our one. Second one is the meshing. In this meshing, see this one is the default mesh is generated. So if I want to change the mesh according to the element length, so that what I have to do means come to mesh, then here mesh control, I have to go for a sizing. In this sizing, first of all I want to click the geometry. So that here in the menu bar we are having the body or element. So that we have to click on that body or element, so that the entire body is going to be selected. Then here we are going command apply. Then here sizing. So element size. So the element size is default, that is 0. Now I want to assign an element size of 1 mm. So 1 mm size I want to take it. After assigning the value here, come to here mesh. Then click on right click, so that update or generate mesh we can take. So I am taken the update. So that Now we can check how the mesh will be modified. So see, this is a mesh, how it is going to be modified. To it, you can see in a front view, then zoom. See here, it is process of the different types of elements. That is, it is a combination of a quadrilateral elements and also the axis symmetric elements here. So now we have to check the statistics so that we can check. So how many number of nodes are there and elements are there. In this particular structure, if I given the mesh size as a 1 mm, so it is totally consisting of a nodes of 34,036 nodes and elements it is 4,733 elements are there. Still I can go for a fine mesh. So here now I am reducing the element size to 0.75 so that I can check. So now we can check the meshing. So there is some more fine mesh is there. So now see, the nodes are increased to a 60,000. From 45,000 to 60,000 it is increased. And also elements is also increased to the 85,000. Okay, that is 1 mm to 0.75 mm. Now the discretization is happened. Okay, then come to here. Next one, boundary conditions we have to apply. So for this boundary conditions, we have to click on static section. So that here what means here it is given as the support. So click on the support. First of all, we have to given the fixed support. According to the whatever the modeling image they are given. See here, this one is representing fixed support. So that in the same manner, we can assign the fixed support. In order to assign the fixed support, we have to click on static section. Then come to view as a isometric view. Okay. Then click on support, fixed support. So here this one is going to be rotate. The fixed support, in order to apply the fixed support, so I have to apply on the left side edge. So I want to rotate this one. Then we can to zoom this one. How we are going to zoom means in a mouse, the center button is going to be scrolled so that it is going to be zoomed. So in this zoom, okay. So here we can by taking the phase selection. Here in menu bar, you can click on the phase and we can to select this phase so that the entire phase is going to be selected in a green color. After selecting this phase, we have to apply. Okay. So after apply, we can click on apply so that here it can show. It is a fixed support is going to be represented with a blue color. Once we are going to be click on the fixed support so that it can take the support is going to be fixed. The edge is going to be, the face of the edge is going to be fixed. Next comes to the loading condition. So once again we can come to the image. So here the loading, it is given in the formation of the 1 Newton per mm square. That means here the loading is given in the formation of the pressure. So the pressure acting on a unit surface area. So that in order to do that loading, again we have to come to a isometric view. That means the loading is going to be takes place upon this edge. Yes. So now we have to come to a loads. In this loads we can given in a different manner. So according to problem we have to select the load. So here we are given as a pressure. So click on the pressure. Then in this pressure we can click on this particular phase apply. Okay. So here the pressure how they are given. So the pressure can be applied in two modes. First of all, in which mode means here the pressure is going to be acted upon the x-axis. So that here you can change the defined by to so normal to components. According to these components, here I can assign as a 1 MPa. Okay, here the fixed support and here the pressure is comes to a 1 APA. That means 1 APA. So here the plus is in x-axis. So 1 APA I am going to be assigned. Then click on the solution. Right click. On the right click we are having the different types of stress. So that is, or you can directly solve. Solution, right click, solve. So it will take some time in order to give the solution. If you can get a like this click mark, tick mark, so the solution is completed. Sometimes you can get a like a thunder symbol with a red color that represents any warnings is generated. That means any errors are raised, so that we can get a thunder symbol in a red color, so that it will generate a message. But you can see here now here we got like a tick mark, that is the solution is completed, and also no messages are generated. If any error is generated, then automatically get the message we can see as a one number, that is message will be generated. So in the message it can tell so why the solution is not completed, what is the error, so due to which, so either there is a drawback in boundary conditions, either there is drawback in discretization of elements, it will represent after solution is over. So now we have to evaluate the results. How we have to evaluate the results means by clicking on the solution we can go to a stress. Here we can take a equivalent stress, that is nothing but von Mises stress. Von Mises is a scientist who developed the stress equation for a 3D object. Whenever the 3D object is subjected to a 3D loading, then 3D stress is going to be generated. In the same manner, we can check the normal stress. In the same manner, we can check the shear stress. So then we have come for a strain, that is von Mises strain. Then come to a deformation, that is total deformation. After getting this, so go for solution, right click, evaluate all results, so that all results will be evaluated. So that first of all come to a equivalent stress, then come to view, front view. So this one is a equivalent stress. Okay. So for my loading, so for my boundary condition is applied on the left side, and here the pressure of a 1 Newton per mm square I am assigned on this right edge, so that here the maximum stress I got as 3.76 MPa is the maximum stress, and minimum stress is 0.005974. So here we are having a like the probe like maximum. If you click on the probe maximum, it is generated where I got a maximum stress. If you are seeing this image, at the bottom and the top surface we got a maximum stress, and we can click on the minimum stress so that it can represent, so at this edges, so here the minimum stress is got. And also we are having the probe. When selecting of the probe, you can click, so wherever we want. If I want in this particular area, I can click so that it will represent. Here there is, if you can see, there are some more regions are generated, like you can check on each region also, on red region and orange color region, and also the yellow color region, and also the green color region, and also here green color region. Like this also you can generate how much amount of stresses are generated, because the ANSYS will generate the simulation image. Simulation is nothing but a graphical representation of an object. Here we can check there are so many nodes are generated, and also elements. So there is total 8,502 elements are generated. Here the stress is find out on each element. Out of the 8,500 elements, it will take time. So on which element we get a maximum and minimum. By using of the simulation image, we can simply find out where the maximum and where the minimum. And comes to next one, total deformation. This is the total deformation image. This is the total deformation image which we got. So, and we can do the animation also by keeping it 10 seconds, and the frames are increased to 30, and you can play the animation, so that for application of the load, how the structure will be displaced, we can easily check. And also here the maximum displacement is 0.00061998, that is 6.1 into 10 to the power of minus 4 mm, and minimum is 0. Like this we can check the deformation. Okay. Then in the same manner, normal stress. So the normal stress is 3.7677 MPa is the maximum, and minimum is minus 0.11762. Then shear stress. Comes to shear stress. Here the maximum is 1.0178 MPa, and minimum is minus 1.0184. That is the shear stress. Then after completion of the result completely, so we can check the report preview, so that in the report preview, whatever the operation we can perform, the complete operations will come in the formation of the report. So if I want to check the solid, so you can click on the solid, so that here it is representing, so here the solid is nothing but a structural steel material, and you can click on the geometry. So the geometry, according to our geometry, we are designed a geometry of length of 100 mm and height of 50 mm, and which is a thickness of 0.5 mm, and based upon these three, length, height and thickness, and also the material, So based upon the material, it can generate the how much amount of volume and how much amount of mass is there. Then comes to sizing, body sizing. Here the body sizing, the element size we are given as the 0.75 mm. Then come to fixed support. So the one end of the end is fixed support, and another end the pressure is going to be applied. That is how much amount of pressure and which coordinate is applied. 1 MPa of pressure, like this. And equivalent stress, equivalent normal stress values, that is maximum, minimum. So all these, and also the total deformation also maximum. What is the maximum and what is the minimum? All these values are going to be represented in the singular column. So thanks for watching the video. Please do like, share and subscribe.